electric current, numericals on the electric current. Okay, so let us see which are the important formulae regarding this topic. We will see one by one. First formula, I is equal to Q upon T. Okay, second one, V is equal to IR. Third, R is equal to rho L upon A. First formula is regarding to determine the current, second is regarding to Ohm's law, that is V is equal to IR. Okay, third, that is resistance. Fourth, conductance. Okay, that is G is equal to 1 upon R. It is reciprocal of the resistance. Conductivity, we know that in previous lecture it is the reciprocal of the resistivity, that is 1 upon rho. Sixth number formula, it is regarding to the series combination. It means whenever the numbers of resistors are connected in series. Okay, so the formula is regarding that Rs is equal to R1 plus R2 plus R3 plus dash 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 up to Rn. Okay, if there are the n number of resistors. Here we are taking just 3. Okay, next 7 number formula, it is regarding to equivalent resistance in parallel combinations, that is 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay, next formula number 8, that is regarding to Joule's law. In previous lecture we saw Joule's law, it is nothing but the I square RT upon H. There are the numbers of the equations, we can represent it in that way. That formula is also represented in the H is directly equal to I square RT. Okay, and so on. We will see in detail when we are taking the example on the basis of the Joule's effect. Next, as I told you, Joule's equation or Joule's formula is also expressed in this way from 8, 9, 10. Okay, so let us see how we can solve the example. What are the requirements? No doubt when we are solving the examples we require certain things. Which are these? We will see one by one. First one, you required a notebook, blank pages, register papers. Second thing, you require a pen set, because sometime what will be happen if you are using the pen, sometime maybe, and that's why it is not working properly. Okay, so that's why you are taking at least 2 to 3 pens. Okay, next, in our course the scientific calculator is allowed, so that's why we are using here a scientific calculator. Okay, if you have these 3 things, so you are able to easily solve the examples. Okay, which are these? Blank pages, pen and calculator. Okay, so let us start the first example of this video. Example number 1. In this example, a current of 0.5 ampere is flowing through a bulb for 10 minutes. Find the charge flowing through the circuit. So in this example, what are the given things to you? Current is given to you, that is 0.5 ampere. I is equal to 0.5 ampere. Time duration is given to you, that is 10 minutes. You know very well, in 1 minute there are how many seconds? There are the 60 seconds. So 10 into 60, that is what? 600 seconds. And you want to find charge. Okay, so we will see one by one. Current is given to you, time is given to you, that is in minute. You will be converted into the second, as I already explained. In 1 minute there are the 60 seconds, so how many minutes, how many seconds in 10 minutes? There are the 600. You multiply 10 into 60. You want to find a charge. Okay, that's why Q is equal to question mark. Sometime charge is indicated by the capital Q or sometime in small q. Okay, so which formula we required? Already in previous slide we saw there are the numbers of formulas. Okay, so on the basis of that we are selecting the proper formula. Okay, so which is applicable here? Yes, this formula, that is I is equal to upon Q by T. So I is the current, Q is the charge and T is the time. So in this formula I is already given to in this example, T is also given, so we want to find Q, so that formula will be rearranged or modified in this way. Q is equal to I into T, because this T is here divided, so it will become here, so it will be multiplying to the I, so that's why you can write Q is equal to I into T. Okay, we are putting the value 0.5 into 600. So what is that? You have the calculator. Okay, that is nothing but the 300. So 300 will be the product of 0.5 and 600. So charge is what? Charge is nothing but the 300. So what is the unit of that charge? It is a coulomb. Okay, are you able to understand? Okay, next we will take another example. In this example, a battery of 12 volt is connected across a resistance of 10 ohm. Calculate the current flowing through the resistance. So which are the given things here? Voltage is given to, that is 12 volt. Resistance is given to, that is 10 ohm, and we want to find what? Current I. So the formula for the I according to Ohm's law we know very well. Ohm's law V is equal to IR. Okay, so what are the given things? Voltage is given to us, resistance is also given to us, and we want to find I. So that formula will be nothing but the V upon I is equal to R. Okay, so we are putting the value. Current it is what? Sorry, voltage it is what? 12 volt. Resistance it is what? 10. So dividation. So what is the ratio? That is 1.2. So 1.2 it is the value regarding the current. So that is nothing but the current is what? Current it is what? 1.2 ampere. Okay. It is what? 1.2 ampere. So next we will take another example. Are you following me? Okay. These are very simple examples in this session. Next we will take another example. Example number 3. In this example, the charge of 600 coulomb is flowing through a circuit for 5 minutes. Find the current in the circuit. Okay, find the current in the circuit. So charge is given to us, that is 600 coulomb. Time is given to us, and find current. Q 600 coulomb, T 5 minutes. It means how many seconds? In 1 minute there are the 60 seconds. So 60 into 5 it is what? 300 seconds. Next current you want to find. We have the formula I is equal to Q upon T. So putting that formula values, and you will get the current. So what is that? Q is 600, T is 300. So that is nothing, 600 upon 300, that is equal to 2. So the current will be flowing in the circuit is what? 2 ampere. Okay. So let us see the another example. Example number 4. In this example, a current of 0.6 ampere flows through a resistance of 25 ohm. Calculate voltage across it. Okay, that is on the basis of the Ohm's law. That is formula number 2. Current 0.6 ampere, resistance 25 volt. Sorry, resistance that is 25 ohm, and voltage we want to find. I is equal to 0.6 ampere. R is 25 ohm, V is equal to question mark. We have the Ohm's law formula, that is V is equal to IR. Putting the value, that is 0.6 I, and R is what? 25. So the answer will be, you can calculate it, you have the calculator, or you can also determine the manually. So your answer will be 15. What is that 15? It is just value. We want to find V is equal to 15 volt. So the voltage across the circuit is what? 15 voltage, or 15 voltage supply is given to that circuit. That's why the 0.6 ampere and current will be flowing through the 25 ohm resistance. Okay, I hope that you are able to understand all these examples, important formulae regarding this topic. Thank you.